All right, yeah, welcome everybody to this HDF webinar. It's been a while, but I hope we will have many more and with greater regularity in the future. It's my great privilege to introduce Martin Probst, who is going to talk about h5rdmtoolbox, a Python research data management toolbox for HDF5. And I can tell you a little bit about it in the sense that how I became aware of it. I mean, there are great resources out there, subscribing to Google Scholar, for example, and as it so happens, I came across a document that he co-authored, and it just popped up on Google Scholar, and I saw it and was intrigued by its content, and as I keep saying, there is a lot of fantastic work being done in the HDF community, and the least we can do is highlight efforts like this. And especially in this day and age, for researchers, not just students, but also professional researchers, there's always this hurdle of they want to do something, and these days, they want to abide by the FAIR principles, for example, so they want to make their data and other things findable, accessible, interoperable, and reproducible. But then it really, when it comes down to doing actual things, unless you have the tools available, you don't have to bootstrap something from scratch. That's really where it gets interesting. And that's my reason why I was so intrigued by this toolbox, because it promised many things and it delivered many things, including that, we probably see a new HDF5-based data standard for a discipline every other week or something like that. But then if you dig deeper, the question is, where is the tooling? How difficult is it actually to get started with something? And that's why I'm so excited about this project, is really it gives you this ability that you can outline a convention without a lot of effort in a simple YAML format. And then you have Python-based tools that actually let you, that's the interesting part, validate or verify if a given HDF5 file actually conforms to that specification. And yeah, that's for me, that's just a big step, and it helps beginners as well as intermediate or even advanced users. And yeah, I'm just going to shut up here. So welcome, Matthias, and thank you again for accepting our invitation, and I look forward to your presentation.
Yeah, thank you very much, Gerd. It's a pleasure to be here, to be invited, and to be able to show and share my work. Quickly share my screen. Yes, I'd like to give a bit of a context around the toolbox, why I started that project. So I'm a PhD student at the Karlsruhe Institute of Technology, specifically at the Institute for Turbomachinery. So I'm mainly faced with fluid dynamic problems, and at a few years ago, I started thinking about how I want to store my data, because I was not quite satisfied with information and data I found from previous works, and I thought, okay, we need to find a good common storage where to put data, and especially annotated with metadata. And then I came across HDF5, and I was very motivated to get it going. And yes, and as you said, Gerd, there were then some practical problems when I tried to work more with it and share it with others. And so the idea of having a toolbox was born, also because I wanted to kind of standardize my data. And yeah, I was not really happy with what I found. So what I want to show in a few slides a bit more about the background and my motivation, and then I give a demo. Hopefully it works. It's all still a little bit work in progress. I'm close to finish from my side, and since we last spoke, quite some changes have been introduced as well, and I'd like to conclude then in the end. So as I already triggered a bit, I was at the beginning when I started working with HDF, or when I found data from previous works, I was not so satisfied with what I found. So if you think of the data value, so the value data and metadata has to me, it goes down over time. You can also say over distance, and this is actually what happened to me when I found data. It was recorded a long time ago and couldn't find people helping me with the metadata that was missing. And this problem is addressed basically in the recent years very strongly from the European Commission, but also on national level in the EU. For example, here in Germany, we have the German National Research Data Infrastructure since, I think, 2020. And that's an association which is addressing data management issues. They are developing methods, bringing people together, and bringing a focus on data management, because we're producing more and more data, but we need to make it usable and reusable as well. And then there are different studies claiming how much it costs us not having fair data. You mentioned it already, what fair is. That is just one principle which is very popular and is oftentimes used to kind of measure or give guidelines how data should look like and how it should be treated. And in the end, a lot comes down to how metadata, and in the scope of HDF5, that's the attributes, how they are used. And so this is the main motivation behind. And in my field, the challenges, I said I'm working in fluid mechanics mainly. We have heterogeneous data sources, so we have data from simulations and experiments. Our setups are changed quite often, and we're missing really standards because it's so diverse, the field, and there is no one standard. There will never be, probably, but the efforts towards small-scale standards, it's just not there yet. And there's much work to be done. And this is a small icon from actually it's the Toolbox icon, and it should illustrate a little bit that we have a data life cycle from planning via collecting, analyzing, sharing, and reusing. And along this data life cycle, we need to keep the data quality high in order to compensate actually the challenges, or tackle the challenges that we see on the left side. Otherwise, and I've seen that image in your background as well from the last webinar, I think, otherwise we have trouble working with the data that we find. And in the end, I think it's also a cultural thing. This is the image in the bottom right, actually saying that we need to focus more on how we organize our data, etc. And we need tools and methods, and that's why I wanted to implement a library that everybody can use, which served my needs, and I think can serve many other needs as well. Just a quick attempt to show where the toolbox actually is located, or what my scope is. So it's a bit complicated, but I try to measure the management effort that you need to reach fair data. And I found on the x-axis maybe something like the complexity of the data sources. So think about Earth observation data, so coming from satellites. There are huge communities and they're heavily relying on many users to use their data, so they are quite standardized and they're quite advanced and they're probably very fair in what they do. So I would set them on the top right somewhere. And on the very left bottom, that's the average PhD student. I would say that it's just starting a small project and it's actually new to the topic, probably has the idea to make data better. And the first step would be to use HDF5 in my eyes, but that is already an initial step that has to be taken. And then to get to fair HDF, that's another step to do. And this is where I see my toolbox sitting, like somewhere between very small and medium to large size projects or collaborations. So along that data life cycle, I think that's the last slide about that. From generation over the conversion to HDF, that's actually the life cycle that I use in my work. We are sharing in repositories or databases until we reuse them again. The toolbox come into play. And two things you already mentioned, Gerd, at the beginning. Like I had this concept of conventions and layouts. And most recently, the fair aspects I introduced using RDF, so linked data technology. Linked data technologies. I will show that later. Yes, so about the toolbox, you can find it on GitHub. There's a documentation on Read the Docs. It can be installed via pip install. And yeah, so it's basically a wrapper around H5 and I have like 5 main submodules. That's so the wrapper around H5 where the access between the user and the file is managed. Then we have the convention, which defines how a file should look like. So a stakeholder would define that. Then I have some database interface. Database is maybe a bit too much said, but we'll see about that. And the layout, which actually can check if the current file is as we wanted. And finally, there's a repository interface I wanted to show today because it's a bit out of scope, where you can interface with repositories like Zenodo, for example, quite easily to upload and download HDF files. And then a lot of other things merged in one submodule. Yeah, so let's go to the demo. And I have to say, I might stretch the HDF5 data model at some point, but as I said, my motivation was to make my workflow be a bit easier and more compact. And I found that this would also help my students and co-workers as well. So I will show this in a Jupyter Notebook. We can import that toolbox and just name it H5TVX. Current version is 1.30A2. Probably will be updated soon. And so the first thing, because I was playing around with HDF5 a lot, and my disk was just going full with files, and I found out that a lot of times you just trying things out. So the toolbox does not require a file name if you don't need it. So it will be in a temporary place. So as you can see here, the syntax is similar to H5 because it's just inherited. But you don't need to give a file name, and the rest is basically the same. And oftentimes I wanted to access the file name, although the file was closed. So I had this idea of having a property, HDF file name, and which is the path to a temporary, you can see it here in the app data local and temporary path. Of course, I could have my test file .hdf mode write, have it in my local a local directory, and then it would just be here. Then it would exist and will maybe make my folder full. And I have to say, so if I don't put a file name here and the session is closed, all those temporary files are being deleted. So that was quite handy. Another way of compacting my code was to have the ability to have attributes in the creation process or creation method, group creation and dataset creation. And that I also needed for the conventions. I will talk about that later. So you can actually, with one line, create the group and dataset alongside with the attributes. That was just a very convenient and compact, nicely readable way for me. Then I had other issues where I wanted to have dictionaries as attributes. And so I decided to wrap actually this attribute class and allow dictionaries, which are just serialized. So if we do this and address it again, we see that we get a dictionary back. And so it's stored as a string, but is interpreted again when we receive it. So that's just a few little tweaks that I used a lot, which helped me a lot. And then the other issue was, because I was working a lot with Jupyter notebooks, I wanted to look into the files, and I was looking for a nice way to have that done. And I decided to have like interactive interface. It's called a dump, so you can call it from outside the file or inside the file. Actually, let's take this here, create the same file again. We can call this dump function from inside as well. And I can toggle actually through the file. See, here's the data set with, so that's just one value. As I have the attribute units, that's just the special things that I will detect. I will put the units and the data type in there. So this, of course, could be a larger array, then it will not be shown here at, in the dump string, but it shows me the size actually of the data set. Yeah, and then you can see you can click around here and see all the other attributes. And I have another attribute here, long name, probably my data set. And then this will be here as well. So that was quite handy to have a quick look into the file, how it looks like. And this avoids opening HDF view or some other GUIs like this. So my data sources are mainly from CSV files or YAML files, or actually dictionaries. So I have some special methods here, but I will jump over that due to time. Maybe we can talk about that later as well. It's possible to have natural naming. There was also, oops, what is happening? Oh, I have to load in here. I have this natural name where I can just address group, for example, which is, you can see it above here, a group in the file, instead of always typing a few letters more or signs more. That was just also just a convenient way again. You can also unselect that if you don't want to do that. And then the next big step was actually, and this is going in the direction of fairness, was to use xarray, a very nice library similar to NumPy, but it's allowing us to have, they call it coordinates and attributes in comparison to HDF attributes and dimension scales. And I thought it would be a very good match if instead of NumPy arrays, X arrays would be returned. So let's do that. I'm creating here again random data. so y and x are dimension scales, time as well, and then I'm creating a variable or a dataset u, the random data. So that's about that. And when I want to retrieve them, I can do that as always, but what I get back now is not an numpy array, but an X array data array. And so I have all the attributes here, which is only one in this case, and the information about the dimension scales, or it's called coordinates in X array. And yeah, even those coordinates had attributes again, so that's quite a nice thing. So information is not lost when I retrieve data, because otherwise I would need to go back to the file, and that was, yeah, always a time-consuming effort. And yeah, so this helped me as well. And then, of course, you can do a lot of things with that. But if you don't want to have an X array, of course, you can just use h5pi or add the property dot values, and then you still will retrieve the numpy array. What else? So yeah, there are some implications by using X array. For example, I just want to highlight a few. You just can simply call plot, and this wonderful plot is shown where the attributes, the metadata, is used on the labels of the axis. So you see the units here automatically interpreted, so that, again, a one-liner, very nice. Yes, I also want to jump over all the other implications that X-array brings. If you're interested in that, we can jump back to that. So this was the first part of having a high-level interface to HDF5, which just helped me and raising the acceptance of using the file format, because if you use the raw h5pi, I had the impression that it was a bit overwhelming from times to times, because you need a lot of expertise. Then the next step really was to introduce a convention. That was a convention for me is that I say I want to have certain attributes mainly in the file. And optimally, during I create a data set, I want to be notified if I'm missing something. I said I'm coming from the fluid mechanical background, so physical data, and the data sets I was writing mostly should have units because I'm storing physical data. So for example, it would be good that there's a notification, hey, you're missing units. And of course, I could have hard-coded it into the toolbox, but not everybody needs a units attribute. So I decided to have it a bit more flexible and introduce conventions. Let's see how this looks like. And currently, I design conventions in YAML files, which is just a text file with a certain syntax. Let's open one. It's not needed to really understand every line here. I refer to the documentation. So there's some header information about how we want to name this convention. And then really you define, okay, I want to have units with the method create dataset, okay? And not with create group as for long name here, but I want to have it with create dataset. Then I want to have a validator that's called units that is hard-coded. You can also write your own validator and make it accessible by the toolbox. But at this point here, the unit will be validated. Otherwise, I could just use the string validator, which checks is it a string or not. And the default value, if you don't pass units, in this case, here it says empty, so it's required. And then you can give this valid or expected, I call it standard attribute, a description. So let's check how that works. So there are some other definitions, but let's skip that. So we read in this convention, we register it. So now it's available in the session. Then we need to enable it that it's actually enabled when we write a new file. And if we do that, you see the following, that create dataset now has changed a little bit because there's a units and it's not within the attribute. So I can just pass it as a parameter. And that's only possible because I just enabled this webinar convention. And if I disable it by enabling none, then this, of course, will raise an error because units is just not a parameter in the h5pi implementation. So I go back. So in the other case, if I don't provide units, then I get another error because I haven't provided the unit, and the standard attribute error says convention webinar convention expects standard attribute units to be provided as an argument, which we did not. I'll put it in again. And now it should work again. What does not work is this. Because that's not a valid unit. As I said, the unit is validated. So that's the principle behind convention. It just interferes during dataset creation or group creation. Yes, so that's okay. We can see the error. It's coming from Pydantic. I use Pydantic in the background to validate. That's another great library. And just for the sake of completeness, let's have a very quick look into creation mode. Creation mode is also defined here, and the validator is defined within the YAML file and says, okay, you can use 3 types of creation modes, just a string. And if I use here numerical invalid, which is not a valid creation mode, then I'm getting an error again. So I can do that as long as I don't get an error anymore. And yeah, that's actually about it. What we can also quickly do is just ask for help if we don't know what to do. And let's ask the create dataset for help. You see the typical parameters, and what appears here is a part about standard attributes. So you could pass units, and symbol was also defined in the convention. And this would not appear if I disable the convention for the session. Oh, sorry, that does not work, of course. And yeah, now this standard attribute is also gone from the dataset docstring. Yes, so now we disabled that. So this is a convention interfering during dataset creation. And the other option is that we have a dataset, an HDF file, and then we have it validated because we, before we want to push it to a repository or a database. Maybe at this point here, I rather discuss, because we're running out of time, discuss the concept. And for that, I need to go to actually the idea of searching through HDF files, which is, to my knowledge, not possible at the h5pi library at the moment. So the idea of layouts in a nutshell is you create a layout object, and then you formulate a list of queries where you say, I'm expecting to find a certain data set with a certain name or with a certain compression method or with certain units, for example. And this could appear 5 times exactly or 1 time, or I don't care about how much, at least it should be there 1 time. So these statements can be phrased into queries. But as I said, we don't have a query function on HDF5 files. Of course, there are tools or libraries that can do that, but they're a bit too heavy for my usage. So let's have a quick look into how I find objects in HDF5 files. So I'm reading in here a vortex pair HDF5 files, which I created earlier, lots of things. And let's say we want to find all data sets or groups which have the attribute units, and it should just exist. If we do this and have a look into the result object, we find actually only one, because we were looking for only find one, so we were looking for one exact match. If I have it a bit more broad, so found any number of this match, then I find a lot of data sets that have a units attribute. And actually the syntax is taken from MongoDB, which is a non-relational database. You can also look for objects that have exact attributes, meter per second, for example. Here, I can have a look into this as well. Again, I was only looking for one exact match. I can look for a specific base name, which is the path without the parents, really. So only U and not U, so root U. I can do that and find that exactly data set. So, and with that query syntax, I go into the layouts and construct the layout. It will be a bit overwhelming if I go through all of that, but that's the basic concept of defining what I'm expecting. Because when I expect something, I expect it to be found in the data set. And now the last question I want to address is, okay, if I want to find something, I need to know what I'm looking for. And of course, units is a reasonable attribute to look for, but maybe some other will use only unit. I decided to use the plural form. So if I don't know that, I'm searching for something which is just not there, but semantically it's there, which brings me to the last topic, which I called HDF5 and RDF. And I think there was a talk, I don't know how long ago, about, I have it open here somewhere, the H5 JSON package and the H5LD package. Well, that's quite a while ago. So this package here is 3 years old, and the idea of actually both packages, especially of this H5LD, which stands for linked data, HDF linked data, was to enrich metadata semantically with semantic web technologies, and RDF is just a framework of describing resources, and we can also use that for HDF5 actually. At this point, I'm basically assuming that you know how RDF works, but I can quickly go, let me quickly explain how RDF works. So RDF stands for Resource Description Framework, and it's just a syntax to describe resources, and it consists of a subject, predicate, and object. So as we would describe the world, and so we could describe me, I'm a subject, I have a name that would be predicate, and Matthias would be the object. And a common thing is to serialize this syntax into a machine-readable form, and one of it is JSON. There are also other forms in which you can turn this or RDF triple. So this is the example for John Lennon, not for me. What is missing here is actually name, could be first name, last name. Here it's the full name. So actually the context is missing a bit. And then we speak about JSON linked data formats, where we say, okay, we are talking about a specific object which has a ID, so an URL on the web. So that exists just once, and that's defined here in DBpedia. And these attributes or predicate here, they are defined if you go to this resource, persons.jsonld. And my idea was to transfer this onto HDF5 attributes, similar to the other projects that I showed, and I will go back to that again. So here again, object John Lennon, name would be the predicate, and the subject is actually denoted with the ID. There should be one more. And if we do that for a lot of objects, and we have a lot of objects in HDF5 as well, like different data sets and groups, then we can have a knowledge graph about the content of the file, or here about the relations that John Lennon has with other persons. So that's very roughly the idea of this linked data technology. How did I do this for HDF? So let me start here. So creating attributes is as we learned, and as it is in H5pi. And then in addition, I have these other interface, let's call it. It's called RDF, and I can access the same attribute objects that already exist. So title already is defined here. And then I can access this title and give it a definition. And what is this doing? I will show you in a minute. Or I can actually at the same time create an attribute with the name in this case, and give it a predicate in terms of the RDF predicate, which is defined here at schema.org. So if we go here, we'll see what a name is. The name of an item, very broad description. So if I run this, you will get, and we dump the content, you see what we saw before, but now you get these little icons here. And they appear because we defined what what name is, because name is schema.org name, and this is the link here. And if I click on that again, you will be jumped there. And this description is actually if you don't have a URL for name because you don't yet have defined it or it doesn't exist, you can just give it a definition. So this will link to nowhere, but it will show a description of an attribute which is otherwise not be visible, or you couldn't implement that other way. And we can do that for more complex data. Let's directly inspect the dump output. So contact here now has 3 icons. So it's a type person. So contact seems to be a person. It has an ID, which is my research ID. So if I click on it, it will jump there. And this contact has an author, first name, and a research ID given here again. So in the background, all this information, which I defined earlier through these RDF interfaces, is interpreted in a visual way. which allows you to very quickly and very distinctly identify what I mean with first name. Because I could also have written just name, and then it's not clear if it's a first name or last name. And I understand that in most cases it's quite obvious for us, but for machines it's not. Yeah, so this is very clear now what I mean with the name, because it's linked to, in this case, a specific ontology or namespace, which is called friend of a friend. So if I click here, I get to the definition of it again. So what to do with that? You can extract this in the JSON LD format as we saw before. If we do this, we just call dump JSON LD, or again, you could have dumped it from inside the file. And then you get a string actually, which I printed here. There are two ways. I set structural to false. A structural means that it should ignore the semantical description of the HDF5 internal layout. So the fact that there are groups and data sets and attributes, it should be ignored, and just the semantic description of what the attribute name is meaning should be included. This is why you see no hint about HDF5 here. However, if I put structural equals true, then this will be a bit bigger. And then you see here's an HDF5 root group. It has members. And this first member is a group, but it's also a person, because with that group, I mean to describe a person, which is me, in this case, and so on. So this is in principle readable by humans with a bit of training, but definitely by machines. You can use Sparkle to query that. I have it in here and it will be uploaded in the repository as well. I don't want to bother you with that. Just one nice thing which you can also do. Just need to find it. Just go through it. Yeah, here, visualization. There's a nice way of graphically have a look into the data set or the HDF5 group, sorry, file from above. And this is shown here. I have to search a bit. Where's the root group? Here. So here we have a file. It has a root group. The root group has a name, / of course. And then you could explore the file graphically a little bit. Yes, and the machine can do that very, very well. And but in the end, what the goal was here is to describe an HDF5 file and the relationships in a semantic way, so it's understandable for everybody. I hope that was not too overwhelming. And the fact that I made this accessible in the toolbox was because this h5 JSON package, it's only exporting into a JSON schema, so there's no semantic in it. So you have to know the schema really. And this one here, I think, so it's 3 years old and there's no more development shown, no example data as far as I know. However, I used what the allotrope data format, and that's, I think, an association or a company, I'm not quite sure. So they're using the same technology in the background, and I'm using the ontology they use as far as I can. So that's, again, in a quite early state, but it works to describe the principal relationships between all the objects. At the current time, it cannot describe like things like the chunks, etc. So this needs to be implemented. But on a high level, it's able to describe the relationships. And I find this JSON-LD file a very suitable way of exchanging HDF data without sending the whole HDF5 file, but just the metadata construct actually. Yes, so this was a very quick walkthrough through the toolbox, which at different stages in my data lifecycle actually that I'm using helped me a lot to like streamline data, to have it more compact while trying to address these FAIR principles. And this is most successfully done with the semantic description here. Yes, so that's from my side, and I'm happy to take a lot of questions and give the answers. So thank you very much.
Mm-hmm. Yes, thank you. I have a question. I mean, this, I don't have to repeat it, but I'm happy to. Fantastic work. What about, I think this is just the beginning, because the next step, and I'm sure you thought about this, would be, let's say I did some kind of campaign where I acquired data or I simulated data, and now I want to upload this to Zenodo, but then you also want to think about at the same time, I mean, I'm saying this, I don't mean to pick on Zenodo, but Zenodo is in a way like a silo.
Yes.
Unless you are on Zenodo, how would you find out that this campaign was deposited? But you obviously have the technology already where you could, for example, at the same time as you create that Zenodo collection, you could create entries, metadata entries in Wikidata, for example. And then, so with the registration in Zenodo, you would have the DOIs and so forth, but then you create the metadata records in Wikidata so that anybody can pretty much find it. And I think that would be an interesting addition to this, perhaps.
Yes. So actually, that was my initial idea of why should I export the HDF file content into a JSON file or JSON LD file. So I wanted to upload all my data on Zenodo, so the one that I wanted to share. And then, as you say, how can I find it? That would be your solution. But once I'm at the Zenodo website or the repository, the idea was that I have next to the HDF file a relatively small file, which would that JSON LD file be. And so you would only have to download that file to and ask that file, hey, what's the content of the HDF file? And you don't need to download 10 gigabytes, you know? And so that's the one solution, and the best solution would not to use Zenodo, of course, but a own server where you can directly interact with. But that was out of my capabilities actually and the infrastructure. So I was thinking about like, okay, compromise between interactivity and large well-maintained storage place, and that was Zenodo for me because it will be there for 50 years.
Mm-hmm, mm-hmm. Yeah, yeah, yeah. We use Wikidata on our C Commons project, and yeah, it's a fantastic resource, and it helps you. It can really act as this, call it the semantic layer on top of, I mean, Zenodo. There are other fine options, and to deposit artifacts, they are really great and everything. But then people make different choices for good reasons.
Yeah.
But then you still want to make the connections, and that's where Wikidata, for example, comes in, because then if you want to visualize it, you can use Scholia or something like that to then have that visual front end, so to speak, where you pull all these things together. Or a Jupyter, nothing wrong with a Jupyter notebook. Yeah. Okay. Other questions?
So I must say, with the layout and the convention thing, I'm not fully satisfied, but and I guess there's probably better solutions of defining layouts. But I'm curious if other groups are working on that as well to have it. So I know that Nexus or so, they have their structure and kind of layout, but it's very specific. And what I was trying to do, but I'm not fully satisfied yet, to have a flexible definition of what I expect to be in a HDF file. And it's just one approach, but I'm sure there are better solutions as well.
Mm-hmm. I think there is sort of an interesting tension between being declarative, such as in your YAML file, and then you can be sort of predicate-based or implicit, as you would be with the layouts. And you basically have, these are two ends of the spectrum. One is sort of the declarative and explicit, if you wish, and the other end of the spectrum is the layout and the implicit. And then, yeah, depending on the domain, if you don't need the flexibility of layouts, you might get away with a YAML file. But then if you need more, yeah, you got to work more. So in that sense, I think it's definitely you have options. Or is it, I mean, I'm sure you can use them in conjunction. So you can have sort of, for the obvious stuff in double quotes, you have a YAML file, plus you could have a layout that then does the sort of the more fine-grained validation or verification.
Yeah, so yeah, the convention kind of thing was that in my work was like others would create data for me, and they so we wanted to reduce the iteration between one creating a data set and the other receiving it and say, I'm missing this and that, and then it goes back and forth. And so during creation, or also when you let other codes that you have written let create data sets or files that you wish to have, that they get immediate response. And then before you would go to a next step where you dump it into a database, so then you would do a final check, because you cannot check everything during runtime. At some point, like I want to have 5 velocity data sets, I can only check that once they are there. So that was the idea, to have it like at the beginning and at the end.
Mm-hmm. Yeah, yeah. And then another interesting area, once you sort of bought into the whole semantic layer, then the question would be, okay, what other opportunities or potential benefits are there? That's sort of where I've seen this in other publications, not so much in allotrope, but then also in engineering, where people then, once you have the semantics, you can actually generate code based on the semantic layer. So depending on what the field is, what are the eigenvalues of my stress tensor or something like that. Okay. Yes, you can write code for that, and that's fine. But if semantically, as part of a bunch of RDF triplets and so forth, it's clear what it is, then yeah, that code can be generated automatically. Nobody has to technically go in there and write it. And I think that's a whole other interesting when it comes to visualization and data analysis and so forth. I think that's another interesting direction.
Yeah, and what it makes you think about how to select attributes, because if you need to think about, does this object, or is this object already described? Do I need to describe it? So everybody understands that. That will help to make metadata more expressive, to more clear to others. Because you always are in your own world and in your naming. but maybe the guy next door already cannot understand it. But if you are forced to think about semantic description, that just gives another push to make it very clear what you mean.
Mm-hmm. Okay. Any other questions? No.
I have a question.
Okay.
So, Matthias,
Yes.
from data management perspective, is there a way to go all the way back to the original source file, for example, CSV file that you converted from? So can you query all the way back to the raw data you created the HDF5?
No, but I see what you mean. So so I have these, that's a good point. I have these special methods, create data set from CSV, for example, which just will try by using pandas to read the table and create the data sets from it. What it is not doing is writing as an attribute or so where the data is coming from. Maybe that is what you mean, which would be helpful.
Yeah, that's what I mean, right?
Yeah, that's a good point. The one issue that I see with it, and probably was the reason I didn't register it, but I could do it. If the file is moved, the CSV file is moved, then what's the reason to keep the file name as an attribute? But of course, if you're having it already in a database or so, then it will not be moved. Maybe that makes sense. Yeah. Yeah. Currently, I'm just converting the data.
Right. So would it be helpful if HDF5 library can provide a way to link those raw data somehow in virtual data set manner? And yeah, that's what I was thinking about, and create some database itself for the raw data as a vector, so people can point back to the original source data.
Yeah, that's called provenance, I guess, and that's
provenance, right? Yeah,
quite an important aspect. The question is, how to track the provenance. I guess the most efficient way would be just to note down the file name or the source where it's coming from. But yeah, and then the question is, did you process the data in between? So I was also thinking about how I could track data operations if I convert one data set into another, how to track that, but it's a very difficult task. And I think the only way to do that is via, for example, JSON LD files. So what I use a lot is a ontology from the NFDI, from this German National Association, which is trying to describe processes, mechanical or engineering processes. And in that way, I could imagine that you also describe where is data coming from before it ends up in an HDF5 file. If that makes sense.
Mm-hmm. Okay.
Yeah, difficult.
Time is up. Yeah, one thing you could also, I mean, instead of tracking the location, you would probably use something that's more content addressing, such as like Git. You just track the hash sum. So if you may not be able to locate that file immediately, but just take the hash of it and store that. So at least you can tell if you find a CSV file, you can tell if it was that one or not that one. And
that's a good point. It's better than nothing.
Yeah. Okay, well, thank you very much for this very insightful presentation. I hope many of you enjoyed it, and hopefully we'll have another interesting speaker on topic for you very soon. And thank you for coming, and come again.
Yeah, thanks for talking.
Thank you very much.
Thank you
for your attendance. Thanks.
Thank you.
Thanks. Bye.